Holly Cummins. Thank you very much for coming against the beer and the swimming pool. I'd like to tell you about some of my experiences as a software engineer and in other areas building stuff. I've come over from London. I'm the technical lead in IBM's Bluemix garage in London. And so when I say that, the first thing a lot of people say is, well, what is a Bluemix garage? And we've got this vision that it's a garage. Well, it's not actually a garage. People are sometimes disappointed when they come to visit us and they discover that there's no cars. What we do in the garage is really about a place to innovate. And the idea is that most of us don't have our best ideas in really big corporate places where we do the things the same way that we've always done. The innovation happens outside of those areas in places like garages. So that's why we came up with the Bluemix garage. Yeah. Let's try. How's that? Is that any better? No. How's that? Better. Okay. Excellent. I'll try and speak up as well. Thank you for telling me. Please do shout again if I go too quiet. And the reason we called it the Bluemix garage rather than just the IBM garage is really about the role that Bluemix plays in innovation. So how many of you have heard of Bluemix? A couple of hands. Bluemix is IBM's cloud solution. So it really goes, it gives you all of the things you'd possibly want to do on the cloud. So it gives you server provisioning, same as you might get on AWS and at a comparable price. But then it gives you a lot of stuff higher up the stack as well. So it gives you a platform. It means you don't need to worry about setting up a runtime. If you want containers, you can run containers. It also gives you a whole bunch of services. There's about 150 services in that catalog. Some of them are fairly standard, like a database, like a NoSQL database. Some of them are really quite cool and things that you can't get anywhere else. So in the garage, my role is as a consultant. I do customer projects. I really love coming to places like this and speaking, but it's not my day job. So please do have a look at that URL. It leads you to a sign-up page for Bluemix, but it's tracked, so then I can tell my boss that it was really worthwhile me taking the time to come out here, which would be good for everybody, and you'll love Bluemix, I promise. So I make stuff as a software engineer, but I definitely didn't start making stuff when I became a software engineer. I think I've been really making stuff almost my whole life. So this was me in 1979, and I wasn't doing software engineering because I was very little, but I was still making stuff. So I had a whole bunch of cuddly toys. I had my teddy bears, and I thought, you know, their life must be a bit boring. What they need is an amusement park. So I built them. You can see here, this is the cuddly toy zip wire. And so I strapped them in, and I had the piece of string running from one side of the room to the other, and then I could send them along it. And I thought, you know, they need somewhere to live. So I made the cuddly toy hotel out of cardboard boxes. And you know, the reason I did this is because making stuff is so much fun. I think we all really like making stuff. So fast forward a few years, and I'd got a bit more sophisticated in the things I made. So I started doing a little dragon and a little knight, and I was very pleased. Fast forward a few more years, and I was in university. Now, does anybody want to have a guess about when this photo was taken, based on the appearance of this computer? Ancient history. So it was in 1998. And what this is called a chaotic double pendulum. And it's a really simple thing. It's just a frame, and then it's got two bits of the pendulum with a hinge in the middle. And there's something really interesting about this system, which is that you can describe it mathematically. You know the equations that govern its motion, because it's really simple. But no matter how much math you do, you can't ever actually predict what it's going to do. And that's why it's a chaotic system. So it's kind of, one of the interesting things about this is that something that's basically really simple, just two bits of metal with a hinge in the middle, can behave in a way that takes you completely by surprise. And we see this. In this case, it didn't really take me by surprise because I knew that was the behavior. But we see this in all sorts of areas with tech. So when text messages were introduced, nobody, not the phone operators, not the people who invented them, nobody thought they were going to be very popular. People thought a phone is a device to allow you to talk to your friends. Maybe some people might want to text, but probably not. Whereas in fact, now, probably most of us never ever use our phone for actually talking to someone. And even if we want real-time communication, we'll send a text message. Probably now, actually, we wouldn't even send a text message, we'd use a messaging service. But the idea is there that the people who create technology, even there, can be really surprised by it. Another reason that pendulum was really satisfying as a project was that I came up with the idea. I did it for my undergraduate dissertation. I built it. So there was quite a few parts to it. There was the metal frame, and I machined that out of stainless steel, which was really good fun. And then I put in the bearings to make it flow smoothly. And then there was the instrumentation as well, because what I wanted to do was I wanted to be able to measure it and graph it and see what it was doing and see if it lined up to the mathematical models. So I built the instrumentation and the electronics as well. And then, of course, I used it. I tried it out. I took the results. I compared them to the models and showed that the character was the same, even though the details were different, because it's not a predictable system. And so that end-to-end flow from having the idea to executing it, to actually being the person who uses it and who maintains it in practice, now we'd call that DevOps. So fast forward a bit more. In 2001, I got my first job, which was quite exciting. So I started working for IBM, and I was a real proper software engineer. And I did bits and pieces for a while. And then in 2002, I started work on my first big project. And what we did when we had a big project, the first thing we would do is we would write some design documents, because it was 2002. And we wouldn't just write a small number of design documents. We would write a 100-page design document, because that seemed like a good idea. And it was worse than that, actually, because on this project, there was about 5 components, and each component had a component owner who wrote a 100-page design document, which meant that there was about 500 pages regularly being printed out of words about what this project was going to do before it had actually done anything. And this is why Agile happened, in case anybody is wondering. So with this design document, the reason it was so big was that we wrote everything down in it. Every single interface in our system, we would write it down. We would write down all of the methods in that interface. We would write down how they would interact. So we'd take this design document, and then when it came time to implement it, we'd turn it into code. But then, of course, stuff would happen, and we'd realize that when we were just thinking about software without actually ever writing software, we didn't get it quite right, did we? So we'd make a little change. We'd make an adjustment. And then we had this fun situation where our code and our design document no longer matched up. And people would be referring to the design document to figure out what it was supposed to do, and it would actually be doing something just a little bit different. So people did some thinking about this, and they thought, what we need to do, the solution here, is to put in some round tripping. So let's take this code and let's use it to feed back to the design document. And you can go round and round this loop as many times as you like. And people thought, well, we could even start at this end, and that was model-driven development, or we could start at this end, go to here, but then make sure that it keeps it all up to date. And this seemed like a really great idea. And compared to having a design document and code that were different from each other, actually it was a pretty good idea. So IBM had a product in this area, which was called Rational Soda. I don't know what this says, because I got it from Google Images, so I hope it doesn't say anything really horrible. But I'm fairly sure at least it says Rational Soda. The other thing that struck me about this when I was looking at it is how much user interfaces have changed since then, because doesn't this look absolutely awful? And it's not because Rational Soda was an awful product, it's just because that was the height of user interface design in 2002. So I looked at Rational Soda and I thought, this is so good. I'm so glad I've discovered this. It's going to save me a lot of pain doing this development. But there was a problem. I was using Linux. What Rational Soda did is it took your code and it turned it into a Microsoft Word document. Microsoft Word did not run on Linux in 2002. So I was a bit stuck. I either had to reinstall my computer to run Windows, which didn't seem like a very good idea for a number of reasons, or I had to continue this manual process of trying to keep 2 copies of the same information in sync. So I looked at both of those options and I thought, these are both really bad options. I know. I'm a software engineer. I can use code to solve my problem. So my code was in Java. And of course, with Java, you have a lot of information about the code. You can use reflection to figure out exactly what's going on. And I'd come from doing a PhD. And when you're doing a PhD, you use LaTeX to generate it. So I thought, this is going to be a really easy problem. All I need to do is take my code, do some processing to it, and then I can have it produce a LaTeX manuscript, and then I'll have a beautiful design document, and everybody will think I'm really, really clever. It didn't work out quite like that, because of course I wanted diagrams as well. I needed diagrams. And to programmatically do diagrams is actually really hard to get all of the boxes in the right sizes and the right shapes and in the prettiest position on the page. So after a while, I realized that I'd actually stopped development on the thing that I was supposed to be working on. And I was now spending all of my time working on the amazing Java to LaTeX document generation system. So this is the sort of problem that Greg Young was describing this morning when he was saying, just don't do it. So did this make my fortune? Can you go to GitHub and find the amazing software? Well, no, you can't. There was a few problems with it. The first problem really was that I was solving a problem that had already been solved. Rational Soda existed. And there was a very small number of people for whom it wasn't the right solution, because the only people who it wouldn't be right for were people who were using Linux. And in 2002, that wasn't very many. So really, I just completely reinvented this wheel. And there was a second problem as well, because it was the wrong wheel to reinvent. If I'd wanted to do some really deep thinking about this problem, the right thing to do wouldn't have been to say, let's generate 100-page design documents more efficiently. The right thing to do would be to say, a 100-page design document is a really stupid idea. Let's just look at the code or find some other way of communicating about what the intention is. So, my first tip for building stuff is don't reinvent wheels unless you have a really good reason. So, fast forward a few more years to 2011. I'd been working on WebSphere for a while in IBM, and there was a lot of us who'd been working on it. And it's such a powerful product, but it was a big product. And a bunch of the really smart people in IBM said, what we need to do is we need to make this smaller and lighter and nicer to use on a laptop, nicer to use in the cloud, while still keeping the behavior of the big WebSphere. So they worked away on this, and they succeeded really well. So they came up with something that was about a 50 meg download. It used about 100 meg of RAM. You could run Java EE applications on it. It was modular. It was dynamic. It was a really, really cool product. It's still one of the things I've worked on that I'm most proud of. And when we saw how small it was and how light it was, we got a bit excited. And this was when Raspberry Pi was coming out as well. So one of my colleagues had the really bright idea, and he said, we can run WebSphere on a Raspberry Pi. And now I think everybody runs everything on Raspberry Pis, but at the time, it was quite a surprising idea that you could take this enterprise software and you could make it work on a Raspberry Pi. So my colleague Simon did that. And then I looked and I said, well, that's really cool, but I need to do something cooler, don't I? So I had an idea. I said, if we can run it on a Raspberry Pi, we can make WebSphere wearable. But a Raspberry Pi, it's small, but it's not so small that you could really fit it in your pocket unless you had really big pockets. So I thought, what I need is I need a hat. And once I have a hat, I can run WebSphere in it. So I did the WebSphere hat, which is the world's first wearable application server. And you can see it was a demo that people remembered, but it wasn't a very dignified demo. So this is me with the server is actually in the hat, and there I am speaking. And I hadn't got all of the wrinkles ironed out, so here's a better photo. And I was just sat doing my work with the application server running on my head, as one does. But I hadn't sorted out any wireless, so you can see that there is the Ethernet cable, which is running out of my head in order to get attached somewhere else. So it wasn't fully mobile, it has to be said. And I had a couple of other problems with the hat demo. It wasn't very reliable because all of the bits, so there was a battery, there was the Pi, there was some sensors, and they were all jumbled around in a hat. And every time I put the hat on my head, and it was quite a floppy hat, every time I put them on my head, they got jumbled around, cables came loose. Often there was a problem with the power supply, because it was a USB power supply, and all you needed to do was give it the tiniest wiggle, and it would just disconnect for a moment. And for a computer, of course, disconnecting for a moment basically means reboot. And for a Raspberry Pi, reboot means 2 minutes. So there were some problems, and I thought, I've got a better idea. I'm going to make a dedicated computer case for this Raspberry Pi. And then I had an even better idea, and I said, I'm not even going to use a Raspberry Pi. I'm going to use a PC Arduino, because that seems like a more modern technology. So in order to make things more robust, I came up with the world's first throwable application server. And you can see, with the benefit of hindsight, I thought, picking up my demo makes it break. So instead what I'm going to do is I'm going to throw it around, and that's going to make it work really well. But these things happen. So the architecture is that we have the computer inside the sphere running Liberty. So the application server is running there. A sphere isn't a very good environment for an application server or any kind of computer, really, because in order to protect it from being thrown around the room, you have to put a lot of padding. And when you put a lot of padding around a computer, what happens? It gets very hot. So I had to put temperature sensors in just to make sure that before the computer melted, I knew to stop the demo and rescue it. And then I could be over here with my tablet, my laptop, whatever, and I could access the web page running in the sphere. I could see how hot it was. This is it. And I'll pass it round, but there's little LEDs, so you can see whether it's running or not. At the moment, it's not running. And then if you access the web page, the lights flash so that you get some sense about how much traffic there is to the sphere. And although it's fun, having the application server running in the IoT device probably isn't the most realistic architecture, because we have the cloud. So really what we want to do is we want to put something very light on the edge, and we want to do the heavy computing in the cloud. So this can operate in 2 modes. It can also connect up to the cloud. How many of you have heard of MQTT? Yeah, 1 or 2 hands. If you're doing IoT, there's a couple of messaging protocols that are competing, and MQTT is one of them. It's a super lightweight, super easy JSON protocol. And so instead of responding directly to requests, the computer just reads the sensors every second and sends it up to the cloud. One of the things that Bluemix has in it is an MQTT broker. And that then talks to the WebSphere Liberty, which is running in Bluemix. And then I can connect to the application, see how hot my server is, that kind of thing. So here it is in action. It's not a very good photo, but that's because the sphere is flying through the room. And here's another one. And again, you can see it's got some quite good height. So I showed this to my mum, and I said, look, I've done this really cool thing. And she looked and she said, Holly, I'm very proud of you, but why would anybody want an application server in a cuddly ball? So I thought about it. I was like, who wouldn't want an application server in a cuddly ball? Clearly. But I did have some problems with it, which probably anybody could have told me, going back to, I said I'm going to make it more robust by throwing it around the room. So the first problem I had was just a hardware one with the PC Duino. For some reason, it could never, ever connect to a monitor. I tried about 6 monitors. None of them would show anything. So that means I had to do everything headless, which is fine when the computer's working really well, but when it does things like lose its IP address, it's a bit of a challenge to diagnose that headlessly. So that was problem 1. But I had some electronic problems as well. So after wiring up the sensors, before I'd even done anything, I got a loose connection. And basically what had happened, it wasn't a loose connection at all. It was a completely broken connection. And in order to fix it, so I can get at the PC Duino, but the connections to these are inside the sphere, so they're sewn up. So I had to take the whole thing apart, fix it, sew it all back together, and then about a day later, another wire snapped. So that was a bit frustrating. I had some other problems as well that were entirely my fault. So this is my kitchen counter. You can see the burns where I put the soldering iron on the kitchen counter, which didn't make me very popular at home. And I had some mechanical problems that really weren't my fault. So I was giving a talk in Germany, and 30 seconds before the talk began, I managed to rip the power connector off the board. And of course, once the power connector is off the board, you can't power it. It's pretty fatal. But luckily, the PC Duino has 2 power connectors. So I was able to get that demo working. And then about a month later, I ripped the other power connector off the board. And so then once it had no power connectors, that really was the end of the PC Duino. Except, there was also a battery socket on the PC Duino. And it was really hard to make it work, but I did eventually manage to wire up some adapters, and I managed to connect a battery to this battery socket. But there was a little bit of a problem, because LEDs and sensors, all of these IoT embedded devices, all expect 5 volts. For reasons that aren't entirely clear to me, standard batteries all produce 3 volts. So this means if you use a standard battery without doing anything fancy to power it, you can just about power the computer. That bit works fine, but the sensors don't work and the lights don't work. So it was a bit sad. And this is what happened. So the problem was worst for the bounce sensor, because what it does is every time it gets thrown, it detects the shock and it says bounce on the web page. And the way it emits a bounce event is that the voltage on the pin drops to 0. But of course, if a pin doesn't have, and if a sensor doesn't have enough voltage, what's it going to emit all of the time? 0, right? So I had to, this is a screen cap, and I had to work quite hard to get the timing right to actually only show this many. And you can see me over there looking quite horrified as I've realized what's happening to my demo. And this is what happens about a second later, is it just went and just filled the screen with bounce, 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 bounce. So that was a bit sad. But I fixed that problem. But I had a further problem, because the motion sensor, I was just testing it at home, and I saw this little puff of smoke come up, and I thought, oh dear. And so it didn't work, and because it was a short, it meant that the whole system didn't work until I'd isolated the part that had the short and taken it out. So, and again, this was at about 10 the night before I was going to fly somewhere to do the demo. So I had no chance of getting a new one then, but I did eventually get a new one. But then I had a further problem, which is that the whole PC Arduino, which had been through quite a lot of abuse by that time, it just stopped working, and I had to buy a new one. So my mum's in Canada, and she always says I don't ring enough, and I never email. So she started stalking me on the internet. So she sometimes finds videos of me. And so she emailed me, and she said, I saw a video of your talk. I thought you handled the fact that the demo didn't work really well. Are there any where the demo does work? And I had to go back to her, and I had to say, actually, no, Mum, there aren't. There's about 10 videos of me doing this talk, and every single time, something different and something horrible happened to the demo. So that was a bit depressing. But after that, twice in a row, it worked perfectly. It was amazing. I think the audience weren't very surprised, and I was like, wow, this has never happened before. But it didn't stay like that. The sphere, because it's got a lot of electronics on it, and because it's quite a strange object, it sometimes gets a lot of questions if I carry it in hand luggage, so I tend to check it, which was fine until I had a connection. I made the connection, my bags didn't make the connection, so this is my lost luggage ticket for that. And I continue to have hardware problems. So the amazing thing that fixed my voltage problems, the pin snapped. And this little bit here is one pin, and that little bit there is another pin, and I absolutely could not get them out. They were stuck. So I bought a shiny new one, but this was what I was doing on Wednesday night. I think I did something wrong putting the switch in, and it doesn't work, and it doesn't charge, and it doesn't power it. And I can probably fix it, but at 10 p.m. on Wednesday night, I didn't have time to fix it. So that's why there's no glow on this thing, because it has no power. But I would have had Wi-Fi problems anyway, actually. So I'll throw it around, and you can have a look. There's a little zipper here, so you can open it and peek at the wires if you're curious. It's a little bit of a throw, but okay. Whoops. The first time I did this talk, of course, some things you want to test and some things you don't want to test. And what happens to my demo when I throw it across the room is the kind of thing that you don't want to test. So I started throwing it and it kept working. And then someone threw it back to me. And it was a really bad throw. It wasn't my fault, and it went slamming into the wall behind me. And I designed this to be able to be thrown. I didn't design it to be able to be thrown at the wall. So sometimes I think, oh, why am I even trying to do this demo? Because it's so unreliable. But I'm in good company, because there's lots of people who've done amazing things, who had a lot of difficulties along the way. So I don't think I'm Thomas Edison, but at least I can have the same level of failures as him, even if I don't actually get the success. So the lesson here really is, I think, that doing things that are different from what we've always done before, it's hard. And I looked at that and I thought, well, I don't want to be standing up here saying I'm an innovator, because really we're all innovators. We all do things that we've never done before, even if other people have done them. And that's when we learn, but that's when we make mistakes and have difficulties. So a friend sent me this. I think you won't be able to read it, but this is from Commit Strip. And basically the guy, he's explaining that this is an amazing new thing for the Raspberry Pi, and the Wi-Fi chip has got so much power, and watch, he's doing it, and it's a game changer for the Internet of Things. And then at the end, the LED is blinking, and everybody goes, wow. And so many Internet of Things demos are actually like this, that there's a lot that has to happen to make it work. But then what we see as a user is something really simple. like a blinking LED. So my partner, after I'd been working on this for a while, and I showed it to him, and I showed him, look, the light blinks. And he said that a lot of my demos are doing something that's actually really, really simple, because I could have just written something that was on the board to make the light blink, and doing that simple thing in a complicated way. And so then I started to think about why I was doing it and what the point was. And I was thinking about it, and just because a lot of things that have a lot of value are hard, but that doesn't mean that everything that's hard has a lot of value. Some things are just hard. So if we go back to my earlier example about trying to generate the documentation for my code, that was really hard. It took a lot of time. Did it have a lot of value? Well, probably not, realistically. And sometimes it can be really hard to let go of these things because we invest so much in them that we want to keep going. But really, we shouldn't cling to a mistake just because we spent a lot of time making it. And we have to know when to stop. And one of the best ways that we can decide whether something is worth doing or whether actually we should stop is feedback. So hopefully the things we're making have some users. And we need to be talking to those users, and we need to be saying, is this what you wanted? Is this solving problems for you? So with the case of the document conversion, I had no users. The only user was me. And when I talked to people about it, nobody said, wow, that's great, can I start using it as well? They all said, oh. And that should have been a red flag to me, that there wasn't going to be a lot of people whose life was made better by what I was doing. And when I do the sphere, people usually, they pay attention and then they say, wow, that's really strange. So I can't decide if that's good feedback or bad feedback. So fast forward a bit more to 2016, this year. We do a lot of innovative projects in the garage. That's our mission. But this is one of the most exciting ones. So I'm just going to see if I can play a little bit of the video. Nope, I can't. That was that. So Simon Wheatcroft, he's a British man, and he does quite amazing things because he runs marathons, which is kind of amazing in itself. And then he runs ultra-marathons because a marathon isn't hard enough. And he's blind, so he can't see where he's running. And there's a lot of blind runners, actually, but what most of them do is they run with a guide. And Simon said, I don't want to run with a guide, I want to run solo. So when he's training, he uses an app called Runkeeper. And they didn't design it to be useful for the blind, but they put in voice prompts saying, you've run 0.5 miles, you've run a mile. And that allows him to know where he is, and he's memorized the route, so he can watch out for obstacles. He knows, oh, at 1 mile, there's a lamppost, I need to be a bit more to the right. But when he's competing, he doesn't know the route. So you'd never, like an ultramarathon can be 150 miles, and you would never run a 150-mile course 20 times in order to memorize it. You run a 150-mile course once, and then you say, I've just run that course, and you never, ever do it again. So he needed a different technology. And he wanted to, when he was looking at these courses, a lot of them have a lot of physical obstacles. But there's an ultramarathon course in the Namibia desert. And he said, I know, deserts don't have anything in them except for sand. So if I have the equivalent of GPS, but for a person that just tells me I need to go left, I need to go right, sends him along the course, that will allow him to compete solo. But of course, when you run in the desert, there's a lot of other challenges because you get dehydrated. The dehydration makes you throw up. So you had one problem, and then you have two problems. And he was telling us about the physical challenges, and they were just awful. You know, his toenails would be falling off, everything. So I think we all thought, that's very interesting that you're going, and I'm really glad it's you that's going, not me. But we wrote him an app, and it was a little iPhone app, and it was actually a really simple app. It just beeped if he was it was a bit like a car parking sensor, so it would beep if he was off course, and that was all he needed. It was something just really simple. But this simple little app enabled him to run the ultramarathon by himself that otherwise he wouldn't have been able to. And he came back and he talked to us about it, and it was really inspiring, because he was saying that as a blind person, there's so many things that we do that that we take for granted that he can't do. So when he had this feeling of running somewhere that he'd never been before without a guide, it was so liberating. So that was really, I think, nice for all of us. But is IBM going to make a fortune off this app? Well, no, because the number of users is 1, and we didn't sell it to him, we gave it to him. So, you can't measure the value like that. So I hope this is right, by the way. This is off Wikipedia, but I got a bit confused. So there was about 5, and I tried to choose the right one. And it's not about how much money IBM earned for doing it, and it's not even about how many users are using it, because it was 1 user. But I think still, this did have a lot of value. And we can tell it had value because people were really interested by it. So there's been so much publicity for it. So I got interviewed by NBC, the BBC interviewed us, Reuters came and interviewed us yesterday, and there's been a lot of articles. And I think the reason people are interested is because it shows how technology can help with something that people thought was impossible. Of course you can't go and run 150 miles by yourself in the desert if you can't see, obviously. And Simon was able to turn that impossible thing into a possible thing. And that's really interesting. So this is Simon's dog. And that's Simon. And how Simon normally works is he's got a collaboration with his guide dog. And what we tried to do was we tried to make the app that was taking the place of his guide dog. But when we wrote it, it was something that really needed both us in the garage and Simon. Because Simon, by himself, he's a pretty smart guy, but he's not a developer, so he couldn't have written the app. Whereas us, we would have never had the idea. And I think even if we'd had the idea, we would have done it wrong. Because there was a lot of assumptions that we made that when we talked to Simon, we realized were wrong. There was stuff like, we thought the right user interface would be, if he's too far left, it says, you're too far left. And he said, no, don't give it a voice. Because after 3 days, you have to pay a lot of attention to understand a voice, and it's actually easier to understand a beep, which is the same reason if your car has a reversing sensor, it doesn't say, eek, eek, stop, you're about to hit the car behind, because that would take too long, and it would be too hard for us to understand. It just goes, beep, 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 beep. So, this feedback, again, between us and Simon, where we would do something, we'd give it to him, and then he'd come back and say, yeah, this is what I wanted, or actually, no, it needs to be like this. It was really powerful. So I want to talk a bit more about collaboration, because I do a lot of demos, and I tend to do them in my own time, because it's not my day job. And I have a microservices demo, and because I've given demos before, it's called Catastrophe. And I was working away on it, and then one of my colleagues said, well, let me pair with you on it. And it got so much better, just in 2 days of us programming on it together, because there was a whole bunch of, the code got better, and I understood some technical things that I hadn't understood before, and I understood why I was doing it better than I did before. And again, that's about that feedback, that the pair programming, he learned stuff and I learned stuff. There's another really useful reason to do pair programming, which is about the bus number. So with the sphere demo, if I get hit by a bus, all knowledge of the sphere goes with me. No one else could ever repair it, and probably no one else would ever want to repair it. Whereas in a team, especially if it's your business, you need to have lots of people in the team able to do stuff. So you need to keep your bus number high, and pair programming helps with the bus number. And the more code you have, the more important this is. So we think of code as something that the more code we write, the better. But actually, the more code we write, the more code someone else has to maintain, or we have to maintain. And that's a bad thing. So in the garage, we do 100% pair programming. We're really strict about it. And this is Sam, who helped me with the catastrophe demo, another colleague. And you can see that we've got it properly set up. So we've got the monitors, and then we've got one laptop, 2 monitors, 2 keyboards. And it works really well. So my next tip for building stuff is find a friend and work with them. And better yet, have lots of friends so that you can rotate, so that the knowledge gets spread as widely as possible. So I want to go back and talk about tools a bit. So with one of the many problems that I hit with the Sphere demo, and I was trying to fix it at 11 at night, because that's when I always fix my demos. And so I tweeted, and I sort of said, I feel so sorry for myself, it's 11 at night, here I am doing my soldering. And someone responded and he said, well, your first problem is that you've got a horrible soldering iron for the problem that you're trying to do. This would be good for a different problem, but not for electronics. And I thought, yes, you're absolutely right. This is the wrong tool. But at 11 at night, I couldn't really fix it. But eventually I did go out and I bought myself a much better soldering iron, and it's got a stand, and it's got the solder remover wire, and it's got the pump. And it was such a small investment, and it made things so much easier. And we do this in software as well. So when we were working on the Simon project, we wanted to get his course data up to a web server. And we knew there was no data in the desert, but we knew that he would have data once a day. So we thought, well, this is easy. We can just store it. We can do an upload. We don't need to use a framework for this. We can just write it ourselves, right? Because how hard can it be? Well, it turns out it's exactly this hard. So this is our Follow Simon website that we did. And this is where his route is supposed to be shown. And you can see there's no route. And we realized the data wasn't coming in, but by then there was nothing we could do to fix it. And I hate this because, this is a confessions talk, so I don't want to just say the good things. But this makes me so mad because we worked so hard, and the app did the main thing that it needed to do, which was to help him run. But this bit just failed, and we couldn't fix it. On the first day, we realized we had a problem. But of course, in the desert, when there's no data, we couldn't get him out any kind of patch. We couldn't get him out any kind of update to try and fix the problem. And it had worked every time we tested it locally. So we still don't know what went wrong. It was just one of those things. So, with the benefit of hindsight, what we should have done is used Bluemix. One of the things we do in the garage is, we use Bluemix for everything, and it's got so many services, it's got so many runtimes, it makes us a lot faster. And in this case, we didn't use Bluemix. But it turns out that Bluemix has a NoSQL database called Cloudant. So it's a fork of CouchDB. But one of the things it has, which is really cool, is these mobile extensions. So you can just have the Cloudant instance on your mobile device, and then it will take care of doing the synchronization for you, which saves you a whole bunch of headache, and it saves you a whole bunch of lost data if something goes wrong. So I wish we'd used that, because it's exactly designed for this problem. And instead what we did was we reinvented a wheel, and it was worse than that, because we reinvented a wheel and we didn't get the wheel right. So, top tip, definitely use the tools available to you. And in the previous talk, he was talking about Haskell, and he was saying that it was worth making that little investment in learning Haskell because it would make your life easier. And I think sometimes when we're not familiar with things, we say, I'm not going to use that because it would be too hard to learn. But if it's going to save you trouble, it's worth making that investment. And I think as well, all of us secretly think that we could do a better job than every existing tool out there. We think, even though I've got lots of other things to do, I'm sure I could write a better offline synchronization than the professionals. I'm sure I could write a better code documentation generator than the professionals. Well, sometimes we can. That's how innovation happens. Sometimes we can't. And there's another reason that we keep building things that maybe we shouldn't. And again, that's because, I think all of us love making stuff. There was, going back to what I did as a child, we find it so satisfying to make stuff that sometimes we don't judge right when we should make something and when we should reuse. So just because you can do something doesn't mean you should. So we have I don't know if you have a similar expression, but there's an expression in England which is as useless as a chocolate teapot. So this is the definition of something that no one should ever make because it is completely useless. Anybody want to guess what the next slide is? That is the chocolate teapot that you can buy. So anything someone will have made, even if it's useless, but you don't have to be one of those people. So here's another example of a case where there is the technology, but it really shouldn't have been done. So I don't know if you can read it, but you can get socks with an RFID chip. It is technologically possible. It's a really dumb idea. So just because you can do something doesn't mean you should. So how do you decide whether something's worth doing or not? We had a client come in, and they had a help desk. And the way their process worked was that an email would come in, and then it needed to get triaged and raised into a ticketing system. And this was done manually. Someone would identify keywords and then decide how it should be routed. And their question was, well, this seems like a pretty stupid thing for a person to be doing. Can a computer do it better? And in particular, they were thinking of Watson. So how many of you have heard of Watson? Yeah, a few of you. Watson is, we call it cognitive computing. And it became quite famous because it won Jeopardy, which was something that before then we thought was impossible. And we've taken the thing that won Jeopardy and we've sliced it up into a whole bunch of services. We've added new services. And so it can solve some really interesting problems with unstructured data. So like these emails are really unstructured. You can't just do a search in the email. So what we did was we said, well, the customer had a hypothesis, which is that they thought a computer could probably do this categorization. So we didn't want to spend like 6 months doing this when we didn't know if it would work or not, because these are difficult problems. So instead we spent 2 weeks, and what we found out at the end was that, yeah, it can do it. It did a really good job. It got it right about 80% of the time, and when it didn't get it right, it was pretty confident that it could route it to a human and say, oh, this one's too hard. So that worked really well. So now we're going forward. Now that we've had that validation, we're going forward, and now we're doing the bigger investment to connect it to the back-end system and actually get the real emails flowing through. And then once we've done that, then we'll repeat round the cycle. So this is something, again, that we try and do a lot in the garage, is we minimize the investment until we know whether it's a good idea. And this isn't new to us. If you've read the Lean Startup book, this is an idea that's very much come from there. And again, it's about the feedback. So we want feedback ourselves too, because we really want to know, well, I've built something, doesn't work. Well, how many of you have found yourself saying this? It worked a second ago, because this happens to me all the time, to the point where I've started to call it demo-driven testing or audience-driven testing, because the number of things I've had that work, and then when someone else is looking, they stop working. And so with the sphere, it's pretty hard to solve this problem, because the things that go wrong with it are mechanical things, and the thing that makes them break is using it. So I don't want to test it more, because then it would break more. But with code, that isn't a problem. So with code, we should always write the test first, then write the code. And that means you know that every bit of code you write is tested. That means you know that if something regresses, you find out about it really fast, rather than a while down the road when it's expensive. So again, it's about the feedback. It's about knowing, well, does my test work? That's why you write it first. And then knowing, does this code work? And then knowing, does the code still work? And of course, you want to automate this. You want to have your tests running automatically. When you do a release, you want it to be really boring. So you want to have as much of the release process automated as possible as well. And there's two reasons for this. One is quality. You want to make sure that if anything regresses, you find out what it is. And you want to make sure that if your user comes to you and says, this wasn't what I wanted, or the business environment has changed, that you can change. And the way you can change quickly is by being automated. So you can have that rapid feedback. And what we do is there's a lot of ways we can do this, but there's a quite nice service in Bluemix just for DevOps and continuous integration. So the first thing we do on every project is we just set up our build pipeline, and then we write the first bit of code. And then that means that it goes out to the web, and within a few hours of starting the project, our user can see whether we're on the right track or not. So definitely continuously deliver. So I know I've talked about a lot, and so I want to summarize a bit with the distilled wisdom of what I've learned. Although I'm still learning and I'm still forgetting, so this is actually probably more what I should have learned, but maybe haven't. And a lot of these principles as well, we have a Bluemix garage method, and a lot of the principles that I've talked about you find maybe in a different form in the Bluemix garage method. So, first one, you may not succeed the first time, or even the 10th time. Definitely don't reinvent wheels unless there's a good reason. Just because it's difficult doesn't mean it's valuable. But there's a lot of ways something can be valuable. It's not just in the number of users or how much money you make off it. So don't go it alone. There's a lot of benefit in working with teams, in sharing knowledge with other people, in getting knowledge from other people. Use the right tools. Take the time to know what tools are out there so that you can be more efficient. Test first, code second, always. Continuous integration, continuous delivery takes a bit of investment, but it's so worth it for a whole bunch of reasons. Business reasons, quality reasons, lots of reasons. So even that's kind of a lot of points. So you could probably boil it down even further to feedback, focus on user value, and have the right tools. And even that actually, the way we know whether we've got user value is by getting feedback from our users. And the reason we want the right tools is so that we can get feedback faster about whether we're doing the right thing. So actually, all of it probably really comes down to feedback. And finally, I think we all love building stuff, so we should keep going with it. So thank you very much. I think I've got 4 minutes for questions.